Good, good. And that's about where we are with the web today. Progressive web apps are a new idea. They're not something that is mainstream. It's not something that every developer needs to be using today, but it has a lot of exciting promise. Now, first of all, what do we mean when we say progressive web apps? So progressive web apps is a marketing term. In essence, it's a term that we use to describe a bunch of really cool technologies that are going to shape the way that web apps will behave in the future. Okay, and giving credit where credit is due, Google really has been the ones from the Chrome team driving this idea and putting together the technologies that fall under this umbrella. I want to focus, though, first on the word progressive, because the word progressive is something that we have been using in the web developer community for a number of years now, really around the idea of progressive enhancement. And this is a key part of our progressive web apps, because progressive enhancement is the idea that we take functionality and we layer it on top of our application. Okay, the old way was that we would give a certain version of an application to one user, and then a user who came along and had a newer browser or a newer device, we would give them a newer version of the website. Progressive enhancement goes against that, and the idea that what we do is we give every user the base functionality, and then as we have users who have newer devices or user agents with more functionality, we can then layer on additional functionality for those users. And that's one of the keys that we have to progressive web apps today. So we're going to talk about 3 key technologies, or groups of technologies. And there are more parts that we can talk about when we talk about progressive web apps, but we're going to focus in on these 3. The first is the W3C Manifest. Okay, so this is the idea that we have one manifest that web developers work for, and it works everywhere. So today, if I want to create a Chrome app, I have a Chrome manifest. If I want to create an app for Firefox OS, I have a separate manifest. If I want to create an app for Windows 10, I have even yet a different manifest. W3C Manifest is bringing these all together into a standard so that we have one JSON-based manifest that just works everywhere. The second feature is service workers. And service workers is a bit of an umbrella itself for a number of new technologies that allow our web apps to do things like run in the background, run when they're offline, and run independently of our page. The third thing that we're going to talk about is the app container. And the app container talks about how we present these progressive web apps to the users. It talks about how they integrate with the operating system, how you install them and how you uninstall them, and how the user can experience that. So let's start out and talk about service workers. Notice they gave me a whole thing of Red Bull here. So if I start going too slow, just let me know, and I'll start pounding the Red Bulls and speed it up a little bit. Okay, to talk about service workers, we're going to talk about promises, about the cache API, notifications, and fetch. And again, there are different things I could talk about, but these are the ones that are important today. Promises. Promises are actually something that is JavaScript-based. Okay, so this is ECMAScript 6 type of stuff that gives us a different way for our functions to interact. Now, there are a number of times that when we want to make a function asynchronous, we'll actually use events to be able to fire the functions at the right time. And events are still really good. They're still really important, especially if you have a one-to-many type of communication, you still need to use events. But if you have a function like we have on the screen here, and we want to say this function A is going to do something, then when it's done, when it returns, it's going to start function B. That's where promises are really good. And I'm going to show you an example of this in a minute. The second technology is fetch. All right, so fetch is a feature that allows us to go out and grab things from the web. And you may be thinking, yeah, well, I can already go grab things from the web. It's called XHR. Well, that's true. We have that. But Fetch actually will fire events every time anything is gotten from the web. That means whether you do make an XHR request, or you load an image, or you load a web page, Fetch is going to handle that. So let's stop here and take a look at these technologies and how they work together. Now, I have a simple page here. Let's see, how does it look? Should be good skies. And then I'm going to pull it up on my browser. It's a blank page, right? It's even blanker now. Let me start the server. All right. Okay, so I'm going to use Fetch to go grab image data and put it onto my image tag here. So you see I have an image tag on my page, and I already have a pointer to my image itself. So what I'm going to do is I'm going to go and fetch the file, okay? So now we go back to our page and we refresh it and nothing changes. Well, nothing that you could see changes. Let me open up my network and refresh it. And you'll see what I'm actually seeing here is I am fetching that image. I'm not doing anything with it yet, but I'm going out to the network and I'm pulling it in. Okay? So Fetch is actually working here. Now we need to tell Fetch what we want to do with that image. So I'm going to go ahead and do a promise. And I'm going to call it inside of then. And I'm going to have it return blob from the response. Now let's stop here and look what I'm doing. I'm telling that my fetch, when you complete, then do the next thing. Okay, then look at the response. I'm calling it with a dot then. A lot of times when we talk about promises that can return a promise, we call them thenable functions. So this function is thenable, which means I can add a then at the end, and then I'm going to either get a positive or a negative response, okay? And then when that happens, I'm going to do another one. Return the image data. And then inside of here, I'm going to create object URL, and then the image data that comes back. And now hopefully, when I reload my page, URL. It should work. All right, I've got a typo somewhere here. Okay. Luckily, I have a backup copy just in case. All right, now let's try it. Oh. All right. This is supposed to show us the image. Start my server again. Blah, blah. row object, my object. Don't you love when you get to troubleshoot on stage? There we go. Wonderful caching. So now I'm returning my image here, all right? Sorry, guys, it's a little hot on stage with the lights. And they told me if I wanted to, I could take my shirt off. But they said I had to keep my pants on. And I told them if I can't take the pants off, it's no deal. I'm just going to stay fully clothed. So is returning an image. Now you're asking, well, that's really wonderful. Why should I use fetch instead of just setting an image source? Well, you should use fetch because it's new, right? No, it's not a good enough reason to use fetch. In fact, we can actually just go back and instead of fetching this, we can delete this. And we can set this to our image. And then we end up with the same result. Now, the reason why fetch is very important for service workers is because fetch gives you that event. You can go and grab something with fetch, and I think there's many times that we'll want to do that. But we're also going to want to use fetch to generate fetch events. So I'm going to move over to Chrome here. Chrome clearly has the best implementation of fetch and service workers out there today. So we're going to move over there to show you what that event looks like. All right, I'm going to reload this same page. And now what I'm going to do is I'm going to register a service worker before I do this. All right, so I'm going to go in here and add a service worker. Now what the service worker is doing here is it's setting the scope, which in this case is going to be my entire domain, to register to this service worker called test SW. All right, and then I am now going to go and refresh the page. Let's turn on our devtools here. The first thing that you're going to see is that it tells me that my service worker is registered. All right. The second thing is I now get this console log here that says yay for fetch. So let's go back and look at our service worker. What I'm doing on this service worker is I'm looking at that event for fetch, and then I am firing a console log that says yay for fetch. Okay? Imagine, though, instead of firing a console log, I could do something else with this fetch event. So now every time I make a network request, I get a fetch event, and I can look at it and I can say, based on that fetch, that maybe I want to pull it from my cache instead of pulling it from the server. Maybe I want to pull it from IndexedDB. Maybe I don't want to show that image at all, and I want to show a substitute image instead. All right? I have the ability to control my network now just by using fetch. So let me go in here and clear this service worker. So I'm going to do this using the Chrome internals. I'm going to unregister it, make sure it has stopped. All right. And now let's move on a little bit and talk about some of these other technologies. Okay, so we have promises, we have fetch, now we have notifications. Well, why are notifications important to service workers? Well, remember, service workers can run in the background. Okay, so they can be doing things while your page is doing something else, which means that there may be times that I want my service worker to be able to alert the user that there's something changed. And so I can use a notification. I have two ways to do it here on the screen. The top one is if I'm inside a service worker, I'm checking to see if I've been given permission to do notifications. And if I have, I fire a notification from the service worker. And if I haven't, I don't, obviously. The second way is if I am on the page itself, I will look and say, I'm going to create a new notification and fire that notification. Okay, so the top one is inside a service worker. The bottom one is on a page. The last piece here is the cache API. All right, now the cache API is an intentful cache for you as a developer. You shouldn't mix this up with the browser cache. There's still a browser cache. It's still going to work the way it does. But this is a cache for you as a developer to put things in and take things out of. You decide when things get put into this cache, and you will decide when things get taken out of them. Now, I have a real small snippet here showing how you would use the cache. You're going to name the cache. You can have multiple caches. This one is named Dependencies Cache. And then I have a list of files, because these are files that I want to put in as a whole. So I'm adding all of these files to the cache, and then I'm using a promise so that when the cache is open, when it's ready, I will then add all my files in this array into the cache. All right? Let's go back to an example here. Now, for this next example, I am going to use a great web app here. This is called Southridge Video. Okay, it's what you would expect from a video app. It's responsive, which that means that it's going to work with the different screen sizes. It works with touch, all right? It works with mouse and keyboard. And this one has a special feature that no other web app does, because no matter what video you ask it to play, it's going to play the video that you want to see instead. And I'm not sure who that handsome redhead ginger guy is in the picture, but it's not Christian. So,
Give me your tots.
So no matter what video, that's the one that you get to watch. It's pretty helpful. So we're going to use this as an example. And I already have service workers attached to this page. Let me walk through what we're doing. The first thing that we're going to do is, on the index page itself, we're going to register the service worker. Okay? So the first step that I'm going to do is I'm going to feature detect whether service workers exist in this browser or not. And that's something really important, because going back to progressive enhancement, we don't want to make service workers a dependency of our application. So if service workers exist, the first thing I do is I ask for permissions. Okay, this is for my notification, so I do a notification request permission, and then I'll give a console log if I get that permission. Now this is where I get into the service worker. We showed the registration on the last example. This is the registration here. The service worker name is service-worker. And the scope is set to the entire domain. So anything that happens on this domain will be controlled by this service worker. All right? The last thing I have here is an event that I'm attaching, an event listener I'm attaching to controller change. And I'll show you where I fire this from the service worker. But this basically fires whenever the state of the service worker changes, and I'm looking for that state to be activated. In other words, I want to know when my service worker is done installing. All right, and when it is, I fire an alert that says you may go offline. So let's jump over to the service worker and see what our code looks like here. Starting at the top of the service worker, I identify a cache. I'm only using one cache in this case, called Dependencies Cache. I then have a list of files that I run in my application. So the reason why I'm going to list these out ahead of time is because these are the ones I know I want to add to my cache. And this is all happening now inside of the install event. So the next thing I do is I'm waiting for this install event. Your install event is going to happen only when the service worker is being installed. Remember, you don't want to open up a new cache every time you run the page. You don't want to add things every time. Otherwise, you're not taking advantage of the cache. You want this to happen once when the service worker is installed. When you install a different service worker, you're going to have a new install run. But in this case, this happens the first time I'm going to run this page. I wait for that event to happen, and then I open my cache. When the cache is open, I'll then add all from my required files here. So this is where I'm adding those files ahead of time. So the fetch is going to go and grab all those files, pull them in, and add them to the cache. And then I'm going to tell it to move on. Don't wait until this happens. Just continue on, OK? The next thing I have is my fetch event. This is where I'm listening to every network call that comes in, looking for that fetch event, and I'm looking at the response, okay? Because one of two things is going to happen with this response. I'm going to check it against the cache, and I do that right here. I do a cache.match, okay? I'm going to check it against the cache. If that file is in there, then I'm going to pull it from the cache. If it's not in there, I'm going to continue on and pull it from the server. Okay, I'm just going to make that fetch event, or that fetch call. Now, every time I pull it from cache, I also fire this console log so that you and I, when we watch it load, know whether the file is coming from cache or whether the file is coming from the server. Now, one of the things you need to know about cache is when you stick a file in a cache, it puts that whole request into the cache, not just the response body that you get back from the server. All right, so it's not just the JPEG image that is put in the cache. It's actually the response that came back to the server that was tied to that URL. So it's like a key-value pair where the URL is the key and the response from that URL is the value. All right, now you can also put key-value pairs in the cache as well, but in this scenario, I'm just looking at those responses. So what ends up happening is when I pull that response from the cache, it looks like to the page that it's coming from the server. All right, the next thing that we're doing is we're looking for the activate event, all right? And we're telling it to continue on. And this is where we are passing in a message. When it is activated, we go up and we tell the page, hey, the state has changed. It is now active. And this is where we fire our alert, okay? So this is one way that the service worker communicates up to the page. All right, let's see this in action. The first thing I'm going to do is go to my service worker internals. Since I ran it, I'm going to unregister it again. Make sure it's all stopped and everything. Okay, so now I'm going to go ahead. Let's put on our tools. And we'll refresh the page here. So the first thing that you see happens is I get my alert on the screen. Remember, this is being driven because the service worker has finished installing, and it tells the page, hey, I'm done installing. The service worker is now taking control of this page. All right, so I get that event that's fired. So now, when I refresh the page again, watch the difference between what happens in my DevTools. Now, all of those events are coming from the cache. Now look at how I'm registering, I'm listing the event here. This is the request that would have been made to the server. Instead of making it to the server, I pull that response right from the cache and pass it back in. Okay, so what this enables me to do is I now have an application that is more performant because I'm not going to the server to get all of these files, and it will also run offline because when I detach my server, which I'll do here, and I reload the page, watch what happens. The same thing that happens when it's online. It pulls from the cache. So one of the really important things about this is I didn't have to change the way I design my page. I'm still loading script tags, or scripts with a script tag. I'm still loading images with an image tag. I'm still loading an HTML page. All of that works just like it does when Service Workers doesn't exist. But when it does, I'm using fetch and cache together to be able to take that same website and make it run offline. Okay? Now, one of the nice things about cache is you're able to add other items to it. It doesn't happen just from a fetch request. Okay, so I want to add other items to this as well. And here's the example. I go in here and I watch my video. Let's mute him. And I have this little link here that says this video is available offline. Actually, it shouldn't be available offline yet, but since we didn't remove the cache, let's go ahead and do that. Okay, this is me deleting the cache there. All right, so for fun, I'm going to stop and unregister this and start again. So now I'm starting with a deleted cache, which is why I'm getting my server not found there. Let's turn the server on. Okay, we see it's re-registered. If I refresh it again, it pulls from the cache. Now I'm going to click on my image.
Like beating up bullies.
And I'll just, this here. I'm going to click on my image, and you'll see the link here says save this video for offline. All right, so how do I know whether that video is online or offline? Well, I'm actually checking the cache to see if this video file is already there. Let's look how we do that. This is a React.js app. So you know I'm cool because I'm using React, right? Did we establish that? Okay, good. We can move on then. So it's a React.js app, and what I'm simply doing is I'm looking at making a call out to my cache to see if there's something in there or not. And I did that, first of all, by setting up a returnable, a Venable function that I call, where I'm calling into my service worker, and then I'm setting up a listener for a post message to get back from it. So when I go back to my service worker, there was one more piece of code down here we didn't talk about yet. And this was an event listener for message. All right, so this is me listening to a post message. Remember that the service workers are web workers. All right, so post messaging, like you talk to a web worker, works the same way with service worker. So what I'm doing here is go to the top. In the message event, the first thing I'm doing is I'm looking to see what type of information I'm looking for in this message. And in this case, I'm checking the URL. So I'm going to check to see if the URL, and this is something that an object I made to pass in. So I'm looking at my cache and seeing if the URL matches something in my cache. If it does match something in my cache, then I know that it is in the cache. I tell my app it's in the cache. If it's not, then it's not in the cache. All right? Now, I'm returning this with post message, talking back up to my function with post message. Now, the second thing that I'm going to do is I'm going to allow myself to make a request to download it. So if I want to independently add this video to the cache, then I can do that. And I have that happen here. I'm opening the cache when it's download, and then I add the URL to the cache. The last thing that I'm doing here is I'm showing on the page a notification that I have inside of a set timeout for 8 seconds. And I don't ever recommend that you set in a set timeout for 8 seconds on your app. It is just a good idea in this scenario because a lot of times this video downloads so quickly, I don't have time to actually show what's happening before the video downloads, so I'm giving myself a little bit of time. All right. So when I go back to my app, now I'm going to go ahead, and what I'm going to do is I'm going to click this link. It's going to start downloading that video independently, and then watch what happens. Okay? I'm going to go to a different website. Okay, so I'm no longer on my website, but remember the service worker runs independently. So the service worker can continue to download that file. When the file is done, it tells me right here that the file has finished downloading. Now when I go back to my app, and I click on the video, it tells me that the video is now available offline. So here's the great thing about caching from a request is it doesn't matter who makes that request. It doesn't matter if the video tag is making that request or if I am explicitly making that request with fetch. Once it's inside the cache, anytime that file is requested, I can return it from the cache. Okay, so now we have a video app that works offline and allows me to download videos offline even when I'm not on the page. All right, so this is the type of functionality that we're used to seeing inside of native apps now coming to our web apps. And the great thing is it can be done progressively. We can add it when that feature's there to continue to give value to our users. Okay, the next thing we want to talk about is the manifest. The manifest, again, is a JSON object that allows us to identify the metadata about our page. So this is going to be things like, first of all, the start URL. I'm going to tell it which is the start page of my app. The second thing is I'm going to tell it what its name is, what its short name is. I tell it how I want to display for the user. I tell it what the scope of the application is. All right, this is important because our web apps need to know when they stop, not just where they start. So for example, if I have a web app that is my video app, but I have a link out to GitHub, I don't want GitHub to open up inside my progressive web app because it's not part of my app. So I want it to open in the default browser, which means I set this scope here. So in this case, it's going to anything that isn't on my domain is going to open up inside the default browser. I'm also then going to set up the icons and those type of things. I'll talk in a minute what I mean here with this API access, but this is a way basically that I'm telling the different environments what my app looks like. So we can look at that here. Now, one of the good things about the manifest that isn't necessarily the case today is the W3C Manifest is meant to live on your web server. Okay, the idea isn't that you should have to take it off your web server and then submit it to the different stores and things like that. The idea is you're able to put it on your web server and manage it like any other file, which means when you update your manifest, the manifest should be able to turn around and update all the places that those apps are installed, right? It's a file that you use along with your development and your production and your pushing out of files. Okay. The last thing, which is what kind of brings all these things together, is the app container. All right, the app container aids with the backgrounding, right? We have that ServiceWorker that runs. We need some place for it to run. So the app container gives you that background space. App management, being able to do things like having a user install and uninstall your app, that control is set by the app container. Now, I'll tell you, there's different levels of implementation of app container. The one that Chrome has on the desktop is not so great, okay? And I'll show you what I mean in a minute. The one that they have on Android is very good. But just like the Google Chrome folks are way ahead on ServiceWorkers and doing fantastic stuff there, I believe that the Windows 10 implementation of the app container is the very best. Okay? And I think this is where they're all going to go. And I'm going to show you what I mean here. All right, so I am in Chrome here. And I'm going to go ahead and install this onto my desktop. So I'm going to do this and add it to my desktop. All right? And it's going to pop up, and it's pulling the image and the name from the W3C Manifest. Okay, that's a great thing. And then I'm going to actually tell it how I want it to open. Do I want it to open as a window, its own window, or do I just want it to open in the browser? Okay, the user can control that there. All right, so now I go to my desktop, and I see my video right here, or sorry, my video app here. I open it up, and it it loads it up in the browser, okay? So that's okay, except if I actually look at my task manager, I don't see Southridge video running there. Instead, I see Google Chrome running, okay? And one of the hard things about this approach is that Google Chrome has to be running for the ServiceWorker to be able to run. Okay, so it's within that environment. If you would close all your instances of Chrome, your service workers would stop as well. Now, one of the best parts about their implementation is the install and the uninstall process. So if I go to my Southridge video here, and I click and do an uninstall, it actually pops me into uninstall Chrome, which is a very good idea. I think that we should all do what they're saying and just uninstall Chrome. Okay, it would make my life as a guy who uses and talks about Edge a lot easier. So you should totally do that. You should totally uninstall Chrome. And then let's move on and look at what we're doing on Windows. Now, for this scenario, I'm going to pull up the live version of my site, which is running on Azure for me. And then I'm going to use a tool I'll talk about in a minute called Manifold JS. This helps you create what we at Microsoft call hosted web apps. Okay, very similar to what Google calls progressive web apps. And I'll tell you, we're moving in the same direction. We are working together to make sure that there's one experience for you developers. You don't have to worry about hosted web apps versus progressive web apps. You should only have to worry about apps, okay? But this is what we call it. And Manifold JS helps you create those across all the different platforms. It'll create it for Google. It'll create it for Firefox. It will also create it inside a container for platforms like iOS and Android. So what I'm going to do is get out of here. And this is a command line tool, but you can also, there's also a version on the website that you can run and make the packages there. In this case, I'm only going to produce the Windows 10 version of the platform, so it doesn't take quite as long. But it's going to go out to the server. It's going to look at the W3C Manifest. It's going to pull in all of the different images and the information that's in that manifest and use it to generate the apps. Okay, so we have our folder here. And then I want to install it. Now, when we create that for you, you'll see you get created not only the application, but also a version for debugging that if you have Visual Studio installed, you can then go ahead and open that up. We do that for all the different platforms. So what you're going to see here is the same application that we see running in the browser is now running inside the app container here. First install. So with our hosted web apps, your app has its own cache. So your browser cache is going to be isolated just for this application, so you know that no one else is going to push things out of your cache there. It's going to work the same way. It's going to be sandboxed. It's actually managed by the OS, so if you have a web app that gets way too big and it needs to be killed, the OS can do that. If it's going to background or go into tombstoning or something like that, that can handle it. If you look at it in the task manager, what you see when this is running is you actually see the Southridge app running on its own. Okay, so now if we do things like install and uninstall of this application, you can do that just for this app, and it's not going to install the entire browser. It'll just install that application. All right, so these are the experiences that create the app-like feeling for your web app. All right, and I really think that we're going to see these app containers work the same way across all the different platforms. Now, the app containers should work on all the devices. All right, you have an app container that runs on Chrome today. So on Chrome on Android today. So if you're in your Android app and you're using a progressive web app, it's going to show up in your app list like all the other apps that you have installed from the Play Store. Same thing on Windows. When it creates that hosted web app, it creates what we call a universal platform app, which means that app is going to run across anything that runs Windows. So it'll be on Xbox, it'll run on a HoloLens, it'll run on a phone, it'll run on a tablet, even an IoT device. Okay? Now, the tool that I just used is actually something that can help you get started with this today. And it's based off the W3C Manifest that we looked at. If you don't have a manifest, it's okay, because Manifold JS will actually help you build that first version of the manifest. It'll then take that and it will build out the app packages for each of the different platforms. All right, so we're doing progressive web apps, which we have just labeled as web right now, but then also the hosted web apps for Windows 10. And we use Cordova as a polyfill to be able to take this same PWA concept into an iOS and Android store application. So you can get into the Google Play Store. And then we have other platforms like iOS and Office and other cool places that web apps can run today. So some of the things that are a little bit of work today for creating PWAs will help you with as well. For example, the images. You might have noticed that I had about 47 images inside my manifest. I blame Android for this, because there are so many different Android devices. You have so many different splash screen sizes and shapes if you want to get all of them. So it's a little bit of work to list them out. So we have an image generator that will take one big image and create all of your other images for it. If you don't have a W3C Manifest today, you can use the command line tool, which is just a NPM package you install and run, and you can create W3C Manifest. Or like I said, you can go onto the website and actually create it there. We have a nice friendly form that you can open up. If you have a manifest, so if, for example, we enter our site here, it will go and collect that information and display it and let you alter it. Or if you don't have one, this is a really great way to just go in, fill out the information that you want to have on your manifest, and have it spit out that JSON object for you that you can then go and add to your website. Okay, we also help you with some of the testing and supporting offline scenarios and things of that sort. So the question is are progressive web apps ready to use today? And I think the answer is definitely yes. Maybe not in its entirety. Maybe not every portion is ready on every platform. But go back to the word progressive. Your app should be written in a way that when those features are there, you should be able to take advantage of it. So if manifest support exists on a platform and you have a manifest there, your users are going to get a better experience with that. Same thing with ServiceWorkers, same thing with App Container. So you can start writing for these features now, and as support comes online, the experience will just continue to get better and better for your users. Okay, so next steps. To learn more about progressive web apps, you should go to Google's page on it. So this is on the Google's developer site. Learn more about what Windows is doing with hosted web apps. You can go to dev.windows.com here. The tool that we showed was Manifold JS. To learn how to develop apps for Windows, you can go to dev.windows.com. And something I didn't have time to talk about today, but you should definitely check out, is Vorlon JS. Vorlon is a framework that is, or a tool set that's built by some of my friends at Microsoft in the community that help you do cross-platform debugging. Now, when we talk about going into app containers on different platforms, on a lot of those platforms, you lose your F12 devtools type of things. So if you're doing it like a hosted web app on Windows, if you're in developer mode and you hit F12, you'll get your F12 tools. But if you're doing this like on an Xbox or inside an iOS app, you don't get that. All right? So what Vorlon does is it gives you a way to do debugging across all those different platforms. Okay, so I suggest that you check that out as well. All right, so questions. I'm open to the questions that you have about progressive web apps, or if you don't have a question, I have some sample ones on the board. I would actually love to hear your responses to them. So we have microphones up in the front. Questions?
Okay, thank you for the talk. I wonder how do the browsers manage the caches, like in terms of like limits?
Yeah.
How much can it be cached? Like, which strategy do they use, like LRU or things like that? Yeah, more around that, like to avoid having cases in which, I mean, the users get like suddenly a gigabyte of cache on their browsers, like things like that. Yeah, thank you.
Okay, so this is the intentful cache that you as a developer get to control. And right now, how big it's going to be is still in flux. All right, I think today, if I remember right on Chrome, it's I think it's 2 gig that they limit you at as far as the files. And every cache is, in essence, its own file that you see. It's not something that you're going to find, you know, like a big folder with a bunch of files in and stuff like that. However, in Windows, we actually don't have a limit for the cache size because we manage that along with as an application, just like we do the other apps. So we'll actually allow you to do that, and it'll be the OS itself that manages how much space you can write to there. And if your application is taking up too much space for critical files, then it'll be sized down and things of that sort. But with the last that I heard from the Chrome team, they also are planning to move to a model exactly like that, where they don't have a limit to those caches. And it will be based on the OS controls to determine what the sizes are limited to.
How are you handling the file expiration date? So when do the files expire? So
here's the great thing about the cache is it's returning the entire response. And you can, at the time that you look at that file, determine whether that is fresh enough for you. Now, I'm going to talk about cache, and then I'll talk about service workers as a whole. So you can actually use the e-tags if you want to determine whether that's a fresh enough file for you. You may say, if the e-tag expires in the next 30 days, I'm going to just go check the server. Okay, if it has a no cache on it, then you can say, I'm not going to use this. It's, you know, no cache. So you have the ability to make those decisions. Remember, you're the one who puts things in and takes them out. You decide how you use them. On a service worker level, each of those are managed one at a time. Okay, so your scope can have one service worker. And in this case, I use the whole domain as a scope. You may just say just this folder, the called app or something is the scope. But only one of those at a time, which means that when you go to install another one, the other one is expired. It's unregistered and it's stopped. Then your new service worker then kicks in. So there is a natural versioning there where you bring in a new service worker, your old one disappears. And then you saw the caches can persist past service workers. You can also just delete all on an uninstall, which is a very common experience.
My question is regarding Linux, because Ubuntu already had web apps earlier. And either it didn't go well or it wasn't in its time, because it went unused.
Yeah.
Does this make it a game changer, or is it just like web apps for Ubuntu?
All right, I'll be honest with you. We don't know yet. I can tell you from a Microsoft perspective, we had web apps with Windows 8. And we did them, they were like a Cordova-style packaged app. And it really did not catch on with web developers like we would hope it would. WebOS before that had apps. Tizen has web apps. There's Firefox OS didn't, they made a shift in their strategy as well because the phone strategy wasn't working for them. I will tell you, I think why this is different is because it's cross-platform. In the past, with Ubuntu and WebOS and Windows 8, you had to do something different to make that web app work on different platforms. Everyone had different rules. This is an extension of what we're already doing in the interoperability space. So the idea is that your apps as they work today can easily become web apps. And a web app can work across multiple platforms. If anything is going to make it work this time, I think that's it. All right, that's the questions that we have. I'll be hanging around for a few more minutes if you have any other questions that you didn't get to ask. But other than that, thank you so much for sitting through this session today.